Can you find the smallest index where the index modulo 10 equals the value at that index? The array might be large, but the condition is simple. Let's see how to solve it efficiently. Given an integer array nums, return the smallest index I such that I mod 10 equals nums I. If no such index exists, return -1. The array length can be up to 100 and values are digits 0 through 9. We need to check each index once and return the first match. The naive approach is a simple linear scan. For each index I, compute I modulo 10 and compare with nums I. This is already big O of n time and big O of 1, constant time space, and there's no redundant work because each index is checked exactly once. So the brute force is actually optimal. The key insight is that we only need the first index satisfying the condition, so we can stop immediately when we find a match. We iterate I from 0 to n1, and if I modulo 10 equals nums I, we return I after the loop. If no match was found, we return -1. This is optimal because in the worst case we must examine every element, and we use only a few integer variables, no extra data structures needed. Let's trace the example 0, 1, 2. Start with I equals 0. 0 modulo 10 is 0, which equals num 0, 0. Condition met, so we return 0 immediately. The loop ends there. That's the smallest index, and it's correct because 0 satisfies the condition and no smaller index exists. For the example, the answer is 0 because 0 modulo 10 equals the element at index 0. This is correct since it's the first index meeting the requirement. You'll spot this pattern when you need the first index satisfying a simple arithmetic condition on the index and value, and the condition only depends on the current index. Also when the search space is linear, an early exit is possible. Time complexity is big O of n because we scan once. Space complexity is big O of 1, constant time, as we only use a few variables. Try the next problem, same pattern. Subscribe for more.